So we've been looking at perimeter and area and some volume and some surface area. Now let's take a look at where these are used and how we're going to use them. So I think it's pretty safe to say that most shapes that we encounter in the real world are not perfect squares or perfect triangles. Okay? Most of them are combinations of different shapes. So that's where we get into what a composite shape is. So a composite shape is formed by combining many other smaller shapes. Okay? So if we take smaller shapes and put them together, we're going to end up with much more complex and larger shapes. Okay? So if we take a look at this, for example, this more or less looks like the face of a house. And it's not just a rectangle, it's not just a triangle, but it's a couple of triangles stuck on top of a rectangle. Okay? So if we needed to determine how much material we would need to build the frame of this house, or how much wood you'd need to face the front of it, we'd need to be able to find the area of this. So it says determine the area of the press board they would need for the back wall of the house. Okay. So this is the back wall of the house here, and as you can see, it's got a cutout for a door. So we're not going to need the press board for the door, because there's going to end up being a hole there, and we'll put a door in after. So we're going to need to break this shape down into much smaller shapes and determine the areas of them individually before we can actually calculate the total area. Try and leave the diagram in the space right there. Okay. So shape 1. Okay, let's take a look at, we'll do, first one will be this triangle right here. Okay. And it would appear as though there are 2 of those. Okay. Or we could look at the total area of the big triangle. It doesn't really matter which way you do it. Either way, we don't have a height. Okay. We don't have a height of it. So I'm going to use, let's drag this down. Okay. I'm going to use the area of the small triangle there. So we've got this little triangle here, and we know that the length of the hypotenuse is 22, and what we need to find is the height. Now if you take a look here, this is going to be half of the length of the 8.53 meters, which means that the base of this has to be 4.26 meters. So to find height, use Pythagorean theorem to find the height, and you should get 21.6 meters as your height. Okay. I'm just going to save a bit of room, and I won't do that height Pythagorean theorem calculation again. If you need to go back and review Pythagorean theorem, go to one of the earlier lessons. So now that we have that, we know the area of this shape has to be half the base times the height. And the base for this triangle, like I said, you could just do the whole big triangle. I'm just going to do the little one first and then deal with the bigger one. So it's going to be half the base, which is 4.26, times the height, which I know is now 21.6. So my total area for this one is going to be 46, right, 46 meters squared. Okay, now my area for this one, since there's 2 of these smaller triangles up here, I'm going to have to multiply that by 2. So it's 2 times 46. So I've got 92 meters squared as my first area. And that takes care of the triangular part at the top. So let's take a look at shape number 2. Shape number 2, we're going to call this big rectangle here. And it's going to include the area of the door. We just want to take the area of this big rectangle. And it's in green. Okay. So draw out my rectangle. It's going to have a base of 8.53, and it's going to be 5.75 at the top. Length, 8.53, and width. Area is equal to length times width, which is equal to my 8.53 meters times my 5.75 meters. Equal to 49.05 meters squared. So since there's only one of these, right, there's only one of these big rectangles, my area 2 is just equal to 49.05 meters squared. And we're done that one. So the last part we have to take into consideration is this door right here. Okay. Now we're looking at the amount of press board that it would take to do the whole face of the building. So we don't actually really want the area of the door. So my door is 81.5 inches by 0.5 inches by 33.5 inches. Okay. Now this one's been, everything else has been in meters, and this one is in inches. Okay. So the first thing we're going to want to do is we're going to want to convert that into meters. Okay. So if we do the 81, let's look at the 81.5 inches. Okay. The conversion is for every 1 meter, we have to get rid of 30, I think it's 39, yeah, 39.37 inches. Oh, almost inches for every 1 meter. So that's equal to 2.07 meters. Similarly, the 33.5 inches is equal to 0.85. Couldn't find it for a second. 0.85 meters. Okay. So when we do our area, length times width, we don't want to use inches because we've been consistently using meters. So instead we're going to use the 2.07 meters times 0.85 meters. Okay. Which gives us 1.76 meters squared. Okay. So area 3 is 1.76 meters squared, and that's the area of my door in blue. Okay. So now we've got all of our individual areas calculated, similar to the way we did when we found surface area before. Now, what we want to do is determine the total area of this composite shape for the pressboard material that we would need. So my area total would be, we want area 1, and we want the total area for 2, but we don't want the area of the door. Okay? We want to get rid of the area of the door. We don't need pressboard for it. It's going to be 92 plus 49.05 minus the 1.76, which equals 139.29 meters squared. That is my, okay, so that would be my total area for the pressboard I would need. So in general, okay, if we need to determine the area of a composite figure, okay, first of all we have to take the shape and we have to break it down into smaller pieces. Okay? If we can't calculate the area of the shape, then we need to cut it into something that we can. Calculate the area of each part, and then add the areas together. Okay? Keep in mind that we need to subtract the areas of any parts that we want to remove from the figure. So just be really careful when you do that final calculation.